Assalamualaikum and good morning guys. So, I feel very smelly today. Oh, it smells bad. But I have this. What is this? This is a perfume. So I just use it and wow, I smell very good. So the question is, how this perfume is made? So this perfume is made is from the distillation column. So if you want to know more about distillation column, let's explore it. Okay, let's go.
Why suppression process matter? Because as you can see in this picture, there is not a clean water into a clean water with a perfume. So in chemical engineering, raw materials are never perfectly clean. They are mixed, contaminated, and full of unwanted stuff. Before we can use anything, water, oil, gas, we need to separate the useful part from the impurities. So that's why separation process literally keep industry running. So without them, no clean water, no medicine, no fuel, and no perfume. So what distillation is? So as you can see in the picture, there's this liquid heating, vapor, condense, and a simple definition that I can give: we heat a liquid, turn it into vapor, and then cool it back into liquid back. And this have separate substance based on the boiling point. In the next video, we will explore exactly how distillation works, step by step, in the simplest way possible that we as a team can provide you. So, what you waiting for? Stay tuned.
Distillation is a method used to separate two liquids with different boiling points. When a mixture is heated, the more volatile component evaporates first and becomes richer in the vapor phase. The less volatile component stays mostly in the liquid. So let's have a look on this flash separation design. From the feed system, the mixture enters the flash drum where it is partially vaporized. Inside the vessel, the more volatile component, the MVC, flashes easily into vapor because of its lower boiling point. This vapor rises onto the top of the vessel and exits through the vapor outlet. From there, it flows into the condenser where it is cooled and turned back into liquid. The condenser liquid is collected as the distillate product. From the same feed system, part of mixture remains in liquid from inside in the flash drum. The liquid is richer in the less volatile component, the LVC, because it has a higher boiling point and does not vaporize easily. The heavier liquid settles naturally at the bottom of the vessel. It then leaves through the bottom of outlet as the bottom product. So, in this flow path, feed enters LVC stays as liquid, liquid settle downward, and finally bottom product is collected. The vessel body or flash drum is where the actual separation happens. When the feed enters, the pressure and temperature conditions cause part of the mixture to instantly vaporize or flash. In short, the vessel body's job is to create stable vapor and liquid region so the MVC can rise upward and the LVC can fall down before they leave through their outlets.
In purifying drinking water, the water is boiled, the steam rise, get cooled down, and we collect the clean, pure water free from salt, mineral, and impurities. This is especially important in places that rely on sweet seawater and contaminated water source. Another familiar use in making essential oil. When the flower or herbs are heated with the water, the vapor carries the oil, then condense and separate into two layers. That's how products like lavender or peppermint are made. Even in perfume manufacturing, distillation plays a huge role in extracting fragrance compound from plants, giving us the scent that we use daily. Besides this application, distillation column also bring important advantage where enhance product quality by producing purer and more consistent output, help to reduce environmental impact by separating harmful gases like carbon dioxide from industrial stream, allowing them to be stored and reused instead of released into the atmosphere. and improve their process efficiency by speeding up the separation and ensuring high quality final product. So why all this important to chemical engineering? Because distillation is one of the core separation process that keep industry running, whether it's water treatment, pharmaceuticals, petrochemicals, or environmental protection. Chemical engineer design, operate, and optimize this system to make them safer, cleaner, and more efficient.